He's president of W.W. Getch Associates. He's the Aurora pump rep, and he's a distributor for Minnesota, North and South Dakota, and western Wisconsin. And he's been working with fire pumps for 17 years, and times I've worked with him, it's been a very good experience. Dave Nelson is also going to be speaking tonight. He's owner and president of Nelson Engineered Sales, and he is the manufacturer's representative for Fire Troll. He's been selling and servicing fire pump controllers since 1977, and he works very closely with Mark on a lot of jobs anyway. Along with Mark and Dave, they're doing the speaking, but Laura Leonard is sitting between them back there. She's the fire troll representative for this region. So if you have any further questions about fire troll's products, I'm sure she'd be able to speak to you. And I think they've got some brochures and so forth out on the table if you're interested also. So without further delay, Mark and Dave.
Cardinal mistake on that for the speed on the next tab.
Thanks, Al. We're going to talk kind of about, we're going to go a little bit over some of the standards and governing bodies of fire pumps, fire pump controls, and then we're going to spend some time going over some of the items in NFPA 2099 that are supposedly going to be implemented this year. And when that gets adopted, so there are some changes in NFPA 2099 that are coming into effect this year. We're going to touch on some of those and also conclude with some discussion regarding some of the installation issues that Dave and I have seen over the years in the field when installing fire pumps and fire pump controls. And if you do have some questions, feel free to interrupt us. Not quite sure how long this thing is going to take, so if you've got questions, let's just get them going, and we'll try to answer them the best we can. The standards and governing bodies that dictate fire pumps and fire pump controls are listed there. Some of those people are here today, and the one that we're going to mainly go over today is the NFPA 20. Which governs fire pumps and fire pump control. One of the things that's new to 99 is that the enclosure or the separation of a fire pump. And, this can have a pretty big impact because there's lots of fire pumps out there that have no enclosure around them whatsoever, especially in warehouses and installations like that where they're just sitting right out in the open. And they are required to have separated by all areas by 2-hour fire rated construction. They do list an exception regarding it is sprinklered. It's a 1-hour fire rated requirement. So that can have a pretty big impact on a lot of installations.
That would be a separate room to be with a mechanical.
I think it can be a mechanical. It doesn't get into that, but I would think as long as it's got that separation, that mechanical would be fine.
Yeah, as long as the mechanical room is 2-hour rated.
Right, yeah.
That's my understanding. Is that
So you don't need a separate room.
right?
Pardon me?
The part that says all other areas, mechanical room would be another area.
Yeah, I understand what you're saying, but I don't know what the actual interpretation definition is. But the reason they changed the wording was, in the past, it's just said shall be protected from damage from fire, wind, earthquake, etc. And what's happened is some people's definition of protected was to put up steel stanchions to keep somebody from running into it with a forklift. And some people have just put chain link fences around them. But what that does is it does protect it somewhat from physical damage. It doesn't do anything to protect it from the heat damage. The electrical controls are heat sensitive. And that's my understanding why NFPA addressed the word. So when you go back to the mechanical room, I assume that's going to apply as a separation area.
Going into some of the areas that involve the pumps and piping. This one's probably more protection area also. An outdoor fire pump installation, other than, if it's in a building other than it's being protected by the fire pump, has to be at least 50 feet away from the protected building. And that's a requirement also that's probably not adhered to all that much. And then they're also required to be provided with protection against possible interruption according to 2-7.1. And I don't remember what that is.
It talks about the standard power requirements
Yeah,
as
for
far as power
the electrical interruption. Yeah.
Yeah.
Now this one here, the elbows and teeth of the center line playing parallel to a horizontal split case pump shaft are permitted when the distance is at least 10 pipe diameters away from the suction flange. And this actually, I think it was in 96, talking about elbows, but I think what they've added here is teeth. They don't allow a teeth to be within 10 pipe diameters of suction flange. And this is, and the reason it's probably not a huge thing to bring up here, but this elbow thing is often ignored or just, there's simply not enough room in the pump room, or it's not laid out in a way that allows this to happen. And so they do allow the elbow or T to be perpendicular to the pump shaft, but they're concerned about flow, kind of radiates towards the outside edge of the impeller, and on double suction split case pump impellers, you can overload one side of the impeller with more flow than the other, causing a drop in performance, vibration, and other things. So that's another item that often gets overlooked. Now this here is a fairly big change too on main relief valves on fire pumps, and mainly to do with the diesel engine driven pumps. In the past, they've just been required on all adjustable speed drivers, irregardless of the pressure rating or the system pressure that it was going to be developed. Now what they've done is basically allowed you to not put a main relief valve as long as you meet this requirement, and that's that 121% of the rated shutoff pressure plus the static suction pressure does not exceed the rating of the system components. And from what I understand, or what I've taken on it is that the overspeeds are set at what?
About 20%.
About 20% on the engine. And that is the only thing that'll shut down the diesel engine under a non-testing type start. So what they're saying is that up until that point, if you're not exceeding the rating for the system components, you can avoid putting on a main relief valve.
Question.
Yes.
What language is there if you've got an electric pump, for instance, you've got a sprinkler system with a relatively high demand, it's a booster pump, kind of a fall in city pressure so that you've got, your demand is 130, 120, 150 pounds for the sake of argument, and your churn pressure is going to be on the order of 200 pounds with an electric pump. What are the various options of relieving that pressure? I mean, My argument would be it's a poorly designed system, but for the sake of argument, that's
Well,
what they have.
I think typically what's done is a main relief valve may be put in, or you've got, pressure reducing valves on some areas of the
Yeah.
systems that are subjected to that.
What are the pros and cons of it?
Well, I don't think a main relief valve is a very good method for relieving overpressurized sprinkler systems. Number one, you either have to pump it back to the suction side of the pump, or you pump it outside the drain or outside the building or whatever. So what happens is that most cases, fire pumps have a relatively flat performance curve. And so to get, say, a 30-pound drop from your rated pressure to your shutoff pressure, whatever it happens to be, you may be bypassing over your rated capacity of the pump every time it comes on, just to achieve that pressure drop you need to be below 175. So, in my opinion, that's not a good way to do it. Only there's a ton of them out there that's exactly what's done with them. I think pressure reducing valves in, if it's a high rise, pressure reducing valves up till the elevation takes care of over pressurization, or you just need to grade your components for, get rated components and that'll handle the pressure. Now, your sprinkler heads are probably the problem there. They're obviously you'd have to have a pressure reducing valve of some sort to handle that. Yes?
What I thought you were saying was you're talking about pressure reducing valves maybe at each floor of a high-rise?
Well, on a high rise, right?
If you had a non-high-rise situation, say a warehouse that had the old ESFR heads and needed to cut that higher pressure off, would you consider a pressure regulating valve right at the discharge of the pump?
Yes. I think that would be superior to having a better installation than having a relief valve that's got a discharge, 1,500 to 2,000 gallons a minute before your pressure's down to where your system components are rated.
Is there any comments in NFPA 20 about doing that, or any concerns about having a large pressure regulating valve in the discharge of a pump?
I haven't seen anything in there other than that, basically what you have to do is account for the pressure drop through there. So it's kind of a catch-22. You need to have more pressure for the pump to handle the loss through the valve, but
Okay.
it should protect the system.
What is the backing? What's that rated for you?
The packing glands themselves, they're only subjected to suction pressure. That's only the suction side of the pump, so they don't see actual discharge pressure. But normally they can handle quite a bit of pressure. I don't know what the actual rating is, but the pump's actually rated for 250 PSI. So. Yes?
Mark, back to the 10 pipe diameters on the elbow.
Yeah.
Are there any requirements when it comes to check valves on the suction side of the fire pump? Any distance between check valves and the pump?
Well, I think just about everything
requires check valves and the entire thing right at the suction side of the pump.
like a backflow or something.
Right.
Yeah, 10 pipe diameters. I believe is what it is, 10 pipe diameters.
But it is in there.
I believe so, yeah. I'm pretty
I
sure
don't remember seeing it as a change, but
Yeah, I don't think it changed from 96 or 96 to 99, but I think just about anything other than an OS and Y valve, and they might even be that too, they don't want really anything within 10 pipe diameters of the pump suction flange.
Thank you.
And, that's great for theory and great for a standard, but, in reality, that's a lot of times very impractical.
if we're gonna do that, you guys are gonna have to start designing us bigger rooms.
Yeah. And that's, and especially in a retrofit situation where you're putting a pump in an existing building, a lot of times these just simply can't be met. But basically, what we're trying to point out is that that's what the standard is. And we've got many pumps out there that have elbows right before the pump. They're in the same plane as the pump shaft, and they operate.
So if you've got an elbow where you came straight down elbow right into the pump, that's acceptable? It's just the plane of the
Correct.
Well, and the pipe's laying horizontal, right?
Well, if it's perpendicular to the pump shaft, on a horizontal split case pump, it's allowable.
Okay.
Because there you're not putting, and that's the reason it's in there, is that on a double suction impeller, the water comes in like this, goes in both sides of the impeller and then out. And then, so if you've got an elbow on that same plane, you have the potential to overload one side more than the other. And if the elbow is in a perpendicular to the pump shaft, on horizontal, if it's vertical, you're not going to have that effect.
Okay, thanks.
I guess if I can back up 1 minute on this, I assume where you're talking about the overpressurization. And I've seen it a couple of times in the city of Minneapolis lately where they've had the wrong design suction pressure. But the other place it seems like we're seeing it more and more is because all the cities around here are raising their city water pressure. I imagine you're seeing a lot of existing systems that are now running high pressure.
This was it's not a local situation. The city, I'm not sure the history of why the pump was sized the way it was. The spring at CSFR, 75-pound end head, and design points, system design points, on the order of 150, 140 pounds. And just given the characteristics of the city water, that's what they ended up with.
What are they doing there?
It's open to discussion.
Okay, so they have, but they don't have a, so it hasn't been, it's not installed yet?
No.
Okay.
I think they're proposing a clay valve, it's one of these big dump water out type deals.
Yeah.
I know a couple of places in Minneapolis recently, they've put pressure reducing valves on the pump discharge to relieve in retrofit situations where they're in retrofit old warehouses. And the city of Minneapolis has been happy with that. So I don't know. They tend to be pretty picky, so.
Well, I think the reducing valve is a better method than the relief valve.
Well, that's why the question is that, we're just trying to get a feel.
Yeah. Now, this is a new one. Pipeline strainers are required for pumps that require the removal of the driver to remove rocks or debris from the pump. They give some parameters on again, 10 pipe diameters from the suction flange. They give sizing criteria on the screen and also for the sized openings. And so the big thing on this is that they limit it to pumps that require the removal of the driver to remove rocks or debris. And at this point, I think that would be pretty much just the vertical inline configuration pumps. It's a close coupled pump. The impeller is actually mounted right onto the motor shaft. It's a special JP shaft motor with a long shaft extension. And in order to remove rocks from that pump, you've got to pull the motor out. There may be some end suction type pumps out there that may require the motor removal to get at the pump there, but I'm not positive on that. So for sure it's going to cover the inline pumps. So and I just checked on these slightly. I don't know, it doesn't say it has to be listed or anything like that. It's basically giving us some size and parameters there and for the screen, but to my knowledge, nobody lists inline pipe strainer, but we've seen a pretty big growth in the use of that vertical inline pump in smaller applications and installations, so that would have an effect. Something to keep in mind. We're at the controller part now, so that's where Dave's going to take over here for a little bit.
I guess controller marking, this issue I put up here because, not so much because it's a change, it's just something I see doesn't happen, because occasionally we get buildings where there's a disconnect ahead of it, and it's not marked, and neither is the fire pump, it's not marked that there is one, or where it is. So it's something for you guys to be aware of. You get into some of these situations, they should be marked. And then also, any disconnect ahead of it should be locked or monitored. And I know that there are some buildings around that aren't, including a couple that I know of in the Twin City area that the disconnects are on the outside wall of the building and they're not locked or monitored. So, this is another big change. This is, was actually in the 96 code book, was pioneered back and forth to UL, and UL said, no, we don't like the language, we're not going to require it. They put it back in the 99 book, and UL has mandated that, to my knowledge, effective September 1st of 2002, all controllers shipped are going to have this provision on the front door in some fashion. Now, there's many different fashions of getting here. One of them is going to be digital display. Some of them, manufacturers I hear, are still looking at using the old analog meters. It's not clear to me, whether one's better than the other. Obviously, digital, some people's forms of digital are going to be different. Fire Control's decided that they're going to display all three-phase voltages on one line and all three-phase currents on the other line below. One screen, one time, one look. Some of the other manufacturers, I think, are going to give you one voltage at a time, one current at a time. They both do the same thing, it's just how hard you got to work to read it. And then some people are going to give you a capability of recording that, and I don't believe everybody is. So there's some record keeping that comes with some of these changes. We're going to, at Fire Control, we're going to a substantial electronics package that's going to give you a lot of features and save you a lot of time troubleshooting, hopefully. But we can get into that more later. I just want to make you aware of the changes coming on the metering side of it. The other big area inside the box and wiring connections that we see missed all the time is actually coming on the alarm side. And it's what I see is it's never in the alarm specifications. You almost always pick up, everybody gets pretty much the top three correct. But then when it comes down to adding a transfer switch, for some reason we missed this. So I get to job sites now and there's a transfer switch required. I always try to find the alarm guy and say, hey, you got to add this point. There's actually another point on there that we'll get to under transfer switches, and that's the monitoring of the emergency side disconnect switch. The code, the way I read 20 is that they want that point monitored also. All the controllers come equipped with these points, alarm points in the controller and available. It's just that the industry hasn't been picking up on the fact that they need to be wired. This is also was in the 96 code for the first time. Hasn't been adopted by UL, therefore you haven't seen it very often, except when an engineer has said, you're going to put it on my job. But it's a pressure recording device. Just like there's always been a requirement for years on diesels, now they put it on the electric side. I actually think it's a good thing, because if people are changing the paper, and you get that service call that say, hey, my pump ran, I don't know why, you go out there and the system's all fine, and now you get a piece of paper to look at that says, hey, the pressure went low. So you end up with a tattletale. Because in systems that are set for automatic stop, it's going to be more than 10 minutes before any of us get there to see why they ran. And this will help that trail. It'll also give you a chance to catch a leak in a system, because you'll see if the jockey pump's running a lot.
Is that something that's going to be required for sure this year or not?
Yeah, that's part of the UL requirement. My understanding is for coming September. This is this is the isolation switch and the monitoring on the transfer switch side. It clearly states in 20, the way I read that, and that's typed right out of there, that emergency isolating switch should be monitored. This is another issue that comes up from time to time. And I don't know for sure that I've got the UFC chapter number right, but I was talking to Minneapolis Fire Marshal yesterday, and he gave me that chapter, but I don't know if it's right or wrong. Didn't have a chance to research it today. But there's a couple of facilities in town where the fuel tank capacity is over 240 gallons, because the NFPA requirement on gallons per horsepower gets you there. Well, it's in the engine room. You know, and so it's technically outside of the 240 gallons, and what's happened is they've said, well, just don't fill it above 240 gallons.
So what basically they're saying is that as long as, if it's in the engine, if it's in the fire pump room, that's when you have a problem.
Right. You know,
If it's in a separate space, you can go with a larger.
if you build a 2-hour space around it, then you can have any volume you need. But if you put it in the, next to the engine, which is where they always are, this is Minnesota's requirement. Now, I don't know that this is everybody's requirement, but this is the Minnesota requirement.
What that limits you to, basically, based on what Dave was talking about, is 1.1 gallons per engine horsepower. Basically, anything over 215 horsepower engine, you might have an issue here. So that's kind of where you're, that's the break point right there. Anything under that, this really shouldn't be an issue. Depending on, again, I guess would depend on the actual size of the tank that you end up getting, because you might have the potential to fill it up beyond that. The last one we had an issue on, they put a big sticker on there and said,
Put a tape mark on the fuel gauge and told the fuel fill guy, big sign there, says, do not fill above this level.
so, because the tank was, I think we had a 300-gallon tank, so they marked it on the level gauge and put a big sign on there that maximum capacity is 40 gallons.
How big of a pump do you see with a 250 horsepower piece of electric?
How big of a tank?
How big of a fire pump is it about capacity?
Yeah, and you can, 250 horsepower.
Well, that's getting pretty big. I mean, it depends on, again, horsepower, or the horsepower is also based on pressure, but well, you'd be up into your large, high pressure at 1,500 or 2,000 gallons a minute probably, or lower volumes at much higher pressures.
This issue actually just came up on Tuesday. We were out here in the cities on a diesel engine startup, and got there and started looking, and the electrical contractor had wired from the engine to the controller in solid core wire. And I'm like, I don't think you can do this. And I went looking, and sure enough, in 20, it says it must be stranded wire. Now, in his defense, I also went looking in the NEC, and it's not stated in the NEC that he has to use stranded wire. So, but he pulled the solid core out and put the stranded in.
And the purpose for that, Dave, is?
Well, the purpose for that is that solid core wire and the vibration of the diesel engines will pull loose out of the terminals, because all the terminal strips are rated for spade connectors, crimp-on spade connectors. You can't crimp a connector to a solid core wire. It just won't stay on there. Matter of fact, when we pulled the plate off the back of the engine cover, we'd never run the engine yet, and one of the wires had already pulled out of the spades. So he said, well, why can't I leave it that way? And he pulled the cover off, and he looked, and he went, oh, okay. You want to take that one?
Sure. These are some items that we, again, that we see in the field. Probably the biggest mistake that I see in the field is how the sensing lines are piped for the fire pump control panel. And it's pretty explicit. It's straightforward, exactly how it's supposed to be done. And that's a little diagram there showing the placement of the check valves in the line, and also the relationship for the sensing line to the system shut-off valve and the check valve. It needs to be between check valve and the system shut-off valve on the fire pump, and you also have to have your check valves that are in the control line itself, and typically those are in there. The biggest thing I see is the actual location of the control line in the system. And probably the other biggest thing that I see is that running a common line, or teeing off with one line and running out over the jockey pump control, and they do need to be separate, and it's, again, that's very explicit in page 20, so there's no change in that, it's just one of the things that we've seen, it's probably the most common problem in the field. And the reason behind that is that they want isolation, so that a problem with one does not affect the other. And mainly what they're concerned about is a problem with the jockey pump affecting the fire pump. You have to service the mercury switch and the jockey pump controller, or the pressure switch. You're not affecting the performance of the fire pump. You're not isolating that, it's not out of service. The reason they have that located prior to the system shut-off valve is so they don't have to drain the whole system to service it. This is one thing that Dave wanted to point out, is that many times you're coming off the bottom of the controller, if you're just down in there, it's pretty hard to utilize that as a test point to verify the operation of your pressure switch. So a good way to accomplish that is just to tee it off a little above that, so you can easily read the gauge, drain the water safely, so it's not spraying up into the control panel, maybe catching the bucket if you have to. And when that is done, it's always good to put a low point drain in there. If you do have to service your switch, you've got a spot to drain the water out of the switch. Otherwise, when you take the pressure switch off, you've got a whole column of water coming out of your control line that's now run off into the inside of the panel, which is never a good situation on an electrical piece of equipment. So just pointing that out. Circulation relief valve. It's another little item that's a lot of creative methods for installing those. The biggest thing probably is a separation from the packing drain lines. Because if they are just run into a common line, you almost always inevitably back up into the packing drain line, and you've got a mess. I've seen them with check valves in there to prevent that from happening, but then while the pump's operating, your packing drains have nowhere to go. So eventually, if your pump runs for a while, they're going to fill up and you're back right to the same problem. The other thing I always recommend is to install a union in the discharge piping of that casing relief valve, because inevitably that's going to have a problem. It's got dirty water in there, and the seat in there is going to get grimed up and it's going to leak. It'll need to be serviced or replaced. And I have no stat or valid evidence of mounting these things vertically or horizontally, but they do seem to work better when they're mounted vertically. I don't know why that is, or I don't have any data to support that other than that. Just what I've seen is they tend to work more trouble-free when they're mounted vertically. And I know that's not possible in all cases, but it seems to help. Floor drains. We got a lot of problems with floor drains, either being inadequate or non-existent. And typically, again, that's in installations, I guess it's more common in installations where the pump is being added afterwards, as opposed to in a new construction. But that is a requirement in NFP 20 that every pump room has to have a floor drain. And piping, punching a hole in a wall, going outside in this state is not a good idea either. So your packing drains are going to eventually freeze up, and now you've got a plug drain in the winter time, plus you've got a mess outside. And so that's, in this particular installation, it was in a pit and no drain. And when we get there, there's already 3 inches of water on the floor. So I don't have that pump's going to have problems later on down the line, because there is no provision to get that water out of it.
And then also, we just did a job last month or two, retrofit job, rehab on an old building, new tenants, and new architecture, all that, but they cut the floor up, put a floor drain in there, but then the floor drain that the engineer specified, and I don't know who the engineer was, He specified a floor drain that had a trap in it, that had a gravity-operated trap. It had to have X amount of water weight on it before it would open. Well, the bottom line is the water back up in the room before the trap opened. So, I mean, there's drains and there's drains, and we can sometimes be our own worst enemy. But as soon as we pulled the cover out, pulled that trap out, drain worked fine. I was at one yesterday, we're talking to the job soup, and he said from the early days of rehab in this building, he told him he needed a large floor drain. The floor drain he's got is about 1.5 inches, and it just won't handle the water coming out of even the drain from the test header. It backs up and runs out into the floor of the building. So, I mean, these are the issues that you guys are fighting. I know it, but on the engineering side of it, for the engineers that are here, you know, we got to find a way to address this. Because the city of Minneapolis, when the inspector that was there, he wanted the drain to be able to handle the full flow of the main drain. That's what he wanted. He wasn't happy with the fact that it had to go upstairs to go outside. So, just throw that out. This is the other big thing that I see on controllers. I thought we got rid of this problem, but now we're seeing it come back again. We got people hooking jockey pumps into the top side of the isolation switch on the main fire pump. And not supposed to go there because that box cannot be used as a junction box. And I have heard from a couple of contractors that, gee, that's where the electrical inspector told them to put it. And I said, well, you go tell him he's wrong, and NEC says he's wrong here. But for your guys' defense, this typically is what it looks like. Little tan wires are the, this happens to be an old job here in the city. It's in a federal building, and that's the way it's been wired from day one. The tan wires are the wires going to the jockey pump. This is a relatively new issue that I see coming up, is that I'm seeing more and more of the walls in the pump room having plywood on them. Some of them it's fire retardant plywood, some of them it's not. In NEC, where the electrical contractor side is, and I don't know who's mounting the controllers, whether it's the sprinkler contractors or the electrical contractor. But the National Electric Code says that those controllers are not supposed to be mounted to a flammable surface. And I can't tell you how new that is. I know that's the way it is in the 99 NEC. And the 99 NEC has been in effect in the state of Minnesota since at least 2000. So all the electrical contractors should be aware of that. This is one of those ones that I just decided to throw in here because we talked about protection of fire pumps. Here's one in a warehouse, and there's not even protection against somebody running into this thing with a forklift on this one. And they've got product stored real close to it. And that flag or that yellow thing you see on Mark's back, that's actually a identifier on this pickup, the company pickup truck snowplow that's parked in the building right next to the fire pump. This is another one. This is in a Minneapolis area hospital. The brand new controller that just was put in, it's in the boiler room. But look I mean, is that protected? Look at all the paper and stuff around that thing. And I don't know, are we writing these things up when we go in and do annual inspections? I don't know how you guys are handling that, but to me, I would be saying something. This is a job that I was not at on startup. It's in northern Minnesota. And it must have been a rural contractor, electrical contractor, because if you look close, he's used Romex wire to wire it. And it says it's supposed to be in rigid or, metal steel tight conduit. And it's obviously not. So, I mean, as contractors, and you guys, he's wiring it, he may not be stuff to you, but bottom line is the pump doesn't run, it's going to be your liability. And this is not for code. This is the module that you'll see in the door of Fire Patrol's new controller. In a normal situation, with the pump stopped and it ready to run, you'll see the stop signal up in the upper left. The upper right, you'll see the system pressure, and then you'll see the time and the date on the line below it. Every half hour, it's going to print that pressure to a electronic recording inside itself. Holds 2,500 events, which we feel should be more than enough unless there's some severe problems in the system. It comes optional with a printer tape and a floppy disk backup. The floppy disk we feel will hold a year's worth of data. And I like that, but it doesn't. The floppy disk doesn't record in real time. It records at midnight every day, takes that day's event and puts it on the disk. But it does save it in an ASCII format so that you can it saves the event logs in one and the date and time in the other column, so that when you take it out, you can throw it in any computer and load it up in a spreadsheet, and then you can sort it by events. It'll tell you how many jockey pump runs you've had, or how many pressure events you've had, or whatever.
I think one of the big advantages of this for contractors, at least on your annual test, you will be able now to record amps and voltage on your annual test without opening up the door and getting inside there. So I think that'll be a nice benefit for annual testing, and the sprinkler contractors not having to deal with volts and amps inside the panel.
Well, weekly, monthly, annually, depending on which version of NFPA 25 you're doing. I mean, if you're doing just the annuals, you'll be able to do that. But if you're doing any of the monthly stuff, I think in the 25 it also requires you to record volts and amps.
Dave, would that be a retrofit feature that customers could buy and put on their pump?
No. No. Because the internal guts of the controller are separate. I mean, it's a totally, inside and outside, it's a different controller.
New controller.
This is a picture I took last March, or no, a year ago last March. 25 says that the electrical connections are supposed to be checked inside the controller. I don't know if the contractors were aware of that or not, but on the annual it says that the connections are supposed to be checked. This one happens, the failure point happens to have been here. That's the factory-made connections. How they got loose or what happened, I have no idea. But bottom line is the destruction here, there was arcing in here until it totally melted the bus bar in 2 phases. Then about 4 months after that, I got another telephone call for a different controller, different location, and I get out there and the wires had burned off the top of the isolating switch. He melted right off. I got to looking and I found out it was aluminum cable. And aluminum cable has a tendency over time to loosen. And as such, the electrical industry says that aluminum conductors are supposed to be disconnected, inspected, redissimilar, greased, and put back together every so often. And different maintenance companies will do it differently, but there are some companies that have aluminum bus and aluminum cabling in their plants where they do that every year at summer shutdown. This unit happened the last 20 years before it burned it up. It's something that, as an industry, we need to be aware of, because there's more aluminum cable out there than I was aware of. I thought everybody was using copper on fire pumps, and they haven't been. It looks like a lot of the stuff done in the early, well, up through the late 70s, probably looks like a lot of that was aluminum wire.
Is it required, copper?
I thought it was required, and I've looked and looked and looked through the code, and I can't find it required. I can tell you that almost all manufacturers today, the controllers that we all ship, are shipping with copper-compatible connectors. And that if you want aluminum compatible, you better tell us on the front end, because it takes a different connector and it has a different radius turn requirement for enclosure clearances. So when we ship a controller, our controllers are marked copper conductors. Here we go back to our floor drainage. I only bring it up because, and you'll see it more obvious in the next slide, but this is a pump room that is, it's pretty dry in normally, but they've been there, run the test and stuff, and water had not run out the drain. We got water, and we can see corrosion beginning on the bottom of the controller. Opened the door and took a photo, and there's actually water, because this controller is an open bottom, sitting on the slab. This design is meant to be on a 2-inch pad, concrete pad. It's not. There's actually water inside the door, laying in the door. There's another one. We replaced this one this summer. But that one was in a pit. The floor drain kept backing up. They kept writing it up, clean floor drain, clean floor drain. Well, the owner kept sending somebody out to clean the drain. What the guy was doing is he's cleaning the drain out and he's setting it next to the drain. So the next time the pump ran, it would wash it right back in the drain again. So, that's the kind of stuff you guys are fighting, and I understand. It's not your fault, but I don't know how we deal with it. But there's another issue, and this photo doesn't actually show it. Disconnect handle on this controller had been removed. Somebody hadn't been able to get into the controller when they wanted to, and they had decided to take the handle off. And so that, to me, that's a huge safety issue. But
Dave, does 20 or 70 require that the controllers be mounted on pads, primary pads, similar like distribution?
no, it does not. The controller, most of the manufacturers have instructions for mounting them. And back then, I know all the switchgear said, it should be on. That controller both of those jobs are over 20 years old. And today we don't build anything in boxes like that with open bottom. And for the most part, we don't build anything that's floor standing. We build everything that stands, if it's floor standing, it stands on legs. So it's at least 12 inches off the ground.
I think legs are shipped standard with all fire pump now, so that you wouldn't have that situation.
This is one I was just to yesterday. This happens to be a diesel controller. It's about a 1969 vintage. You can see there's corrosion running out of the relay sockets. There's been water in this controller. And somebody's wrote it up, said it's not repeatable anymore, and they wanted somebody to look at replacing it. I went to look at, what it was going to take to replace it, and I decided, well, no time like the present to bring this up, because this is another issue for the annual reports. And if you see a controller that has, rust running on the inside panel, I'd bring it to somebody's attention, because something hasn't been right in that controller at some time. When this is the inside, This is one of many terminal strips, and you can see the rust on the screws here. And so there's probably corroded connections there, and that's, I'm sure, another reason that this thing's not repeatable. But if you look right up here, that's the fitting for the connection to the internal chart recorder. It came from the factory back at this time frame. They used rubber hoses. And talking to the maintenance department guys, they said, yeah, we know of at least 2 hoses that burst in that controller. And they replaced the hoses and went on. Well, and then the Romex you see here is where they've wired power out to the external recorder that they've installed. So now it's no longer a listed controller because it's been field modified. And it has this control here, this corrosion issue that was just laying there waiting to happen. I don't know. Again, I don't know what to tell you. There's nothing I can tell you to do except ask you that, please, let's write this stuff up. It's not so much that I'm worried about selling new equipment, but I guarantee you, I don't want that to be my piece of equipment out there and not know about it. Because what I tell them if I run into a situation like this is, that controller's been flooded, it's time to replace it. Because they had spraying water in there to the point where the sockets on the front are obviously damaged because of the corrosion, and the internal wiring is suspect. I think that's it.
Question?
Is there any NEMA rating requirement for fire pump controllers? To keep water from...
Type 2 is a minimum, I guess.
Type 2 is the minimum standard. I mean, that's, everybody's using the Type 2 as their standard.
And that's not really waterproof, is it?
No.
That's dustproof? Is that
It's drip-proof, I think.
drip-proof?
It's got a gasketed door and a little drip cover that kind of goes over the top of it down. But
That's, I mean, we could go on and on. We got some time. Right here, if you look here at the connectors on the top here, those are watertight connectors. This one here is the 2-hour fire rated cable, and then that's a watertight connector. This here is the alarm cable, and it's rigid, and that's a watertight connector. What we see a lot of, what I'm seeing more and more, is intermediate and sometimes EMT conduit, which EMT is not accepted. The way the code book reads, it says rigid, intermediate, or flexible metal liquid type. But what we see a lot of is people are coming into these boxes on the top with standard punch connectors. And then they stick the conduit in it and tighten the set screw. Well, if there's any water coming on anything above that controller, it's going to run right down that conduit, hit that, and go right inside the box. And a lot of the wiring, most of the wiring, the electricians put it in the closest possible place to the disconnect. So where's it going? Right on top of the disconnect. Now, is there a code issue here? No, there's not. But to me, it's like there's a common sense issue here. That some of this should go along with the electrical contractor's common sense. But they're looking at this as any other electrical box. They're not looking at it as something that's life safety and possibly affected by water. And that's where you guys come in. It's up to us to raise the level.
any other questions?
I got one more.
Yep.
Can you go back to your sensing line? Where you look at that sensing? Right there. Those check valves there
Yep.
on the sensing line. The flow is going to be going from the
Flow direction is from the controller to the system.
If you look at the arrow here, they're installed backwards. And that's the way they're supposed to be installed. The idea, what they do is they drill a 3/16 orifice in there, or 3/32. And that gets the water in. The idea behind using the check valve instead of an orifice union is that if it gets plugged, the check valve will swing open and let the pressure drop. But if an orifice union ever got plugged, there's no guarantee that the plug's going to blow out if the pressure drops in the system.
So the installing contractor always drills that out.
I don't know if you guys buy them drilled or you drill them.
Buy and drill.
Buy them drilled?
I think this check valve's the better intervention, or just what they mentioned. It's more of a fail-safe, so that if your system pressure drops, it's opening, and your switch is going to see that drop.
One more question, Mark. Is it a code issue that the nomenclature go on the plate, on the base of the pump?
No. Whether it's actually mounted on the bottom. There's actually two nameplates on every fire pump. There's a pump nameplate, and then there's this BNF, or the UL-FM nameplate. That's probably the one you're talking about, the left-hand that's mounted on the actual base of the pump that you cannot read after a few years. No, I don't think so, because I know that Aurora normally is not on there, they're mowing up on the pump head, but that certainly doesn't preclude them from being, illegible in a few years.
Kurt?
Mark, a casing relief valve on a diesel fire pump.
Not required. Is that your question?
Well,
Yeah,
As long as you're...
as long as it's not radiator cooled.
Yeah, if it's got it, and all of them have heat exchangers on them, but if it is a radiator cooled engine, then it would be fine. But that would be unusual.
But we got a couple of those small radiator cooled ones
That's true.
around that, they need a casing relief valve.
But the flow rate through the heat exchanger is normally adequate to provide cooling for pumps.
Anybody else?
Thanks, guys.
Thanks.
Appreciate it. Thanks a lot, Mark. Dave, appreciate that. Very good.